This is the Screaming Straws experiment, and I think you're going to see very well where this title comes from. As the title suggests, you're going to need a straw, a drinking straw. I'm going to choose the blue one, and you'll notice straight away this is one of those wide milkshake straws. This doesn't work with the really thin straws, so don't use the really thin ones. A wide straw like this, like a milkshake straw. This is actually a bendy milkshake straw, but you don't need a bendy one. You can just use a straight straw. You also need a pair of scissors. I'm going to use these small scissors initially. First thing I want you to do is cut the straw in half. If it's a normal length straw, like most straws are about the same length when you buy them, I want you to cut it in half to make it a bit shorter, about half, because it's easier to do with a shorter straw, to be honest. So I'm just going to hold it here and I'm going to cut it in half. Oops. Now, you're going to notice that I've got roughly two halves here. Now, of course, I was using a bendy straw. I am using a bendy straw. And one of these pieces, of course, is the bendy piece. I'm going to show you this experiment using the straight piece. But of course, you might then think, oh, I wonder what will happen if I use the bendy piece. So that's something for you to keep if you have a bendy straw. Watch carefully. So here's the piece of straw I'm going to use. I'm going to squash one end flat, nice and flat. It doesn't matter what end you squash, just make sure you give it a good squeeze. It won't stay flat, but I'm going to crease it by doing this. You'll see little creases, little edges. And then I'm going to get my scissors and I'm going to cut a point shape on the end very carefully. Now, to get an idea of the shape of the point, I suggest that you cut a point shape that looks a bit like the shape of a pen or a pencil, okay? A bit like a pen or a pencil shape. So long and narrow rather than a short, stubby one. So long and narrow. You'll notice I've made it a tiny bit flat at one end. This is important because although the experiment will work with a perfectly sharp straw, of course it can be a bit dangerous, so I recommend making it a tiny bit flat. So if you do cut it and it looks too sharp, just get your scissors and just snip the end off to make it a bit flat. Mine's already a little bit flat. The reason for this is because if that feels too sharp, it's not going to hurt your finger because your skin on your finger is actually quite tough and it won't pierce your finger. But this experiment, I'm going to be putting these points in my mouth and against my lips. And if that's too sharp, you can dig your lips and you don't want that to happen. So make it a little bit flat. Okay, so this is what I want you to do. I want you to take your straw. I want you to squeeze those 2 points together because you'll notice there are 2 points there. I hope you can see them. There are 2 points. I want you to squeeze them flat against each other, but then use your lips to do that. Squeeze it very firmly and blow hard. Over to you. I'm hoping, with a bit of practice, you got this sound. Some of you probably didn't get that immediately, so you would have blown. You've got lots of air coming out, but no sound. If that happens, it means you've got to squeeze harder. Now, of course, sometimes people squeeze really hard and no air comes out. That's no good either. You've got to have air moving. So maybe if that's happening for you, don't squeeze quite so hard. But I've done this experiment with children from as young as 3 and 4, right up to adults, so I know everybody can do this. Okay, so what's going on with this experiment? Let me remind you of some of the things you, I'm sure, would have noticed as you did this experiment. When you got that sound, which I hope you did, I'm sure you noticed something on your lips. You should have noticed a movement, a tingling feeling. Now, what was actually happening was those 2 points were moving, opening and closing really fast against your lips, and that's what you would have felt, a vibration. When it moved really quickly from side to side, we would call that a vibration. You felt that on your lips. So that helps us understand already what's going on. When you blow air into that tube, fast flowing air doesn't push as hard against the edges it's flowing past as slower moving air. So when you blow fast flowing air in there, the pressure, the push of the air inside those flaps goes down a bit. And in fact, the air outside, or your lips, then pushes harder and squashes the points together. But of course, once it's closed, no more air can go through. And actually, they ping open a bit. But when they ping open a bit, more air flows in. And the same thing happens again. You get a low pressure in there, like a suction effect. The higher pressure from outside causes them to close. And the same thing happens again. And then they ping open again. And the same thing happens again. So it just keeps happening and happening. Now some of you might think, well, just a minute, Dr. Mark, you've got this in your mouth. That's your lips that are causing those points to squash together. That's true. But there's another way of doing this where you don't actually have to squeeze with your lips. I'm actually going to put my lips here. And I want you to watch and listen that my lips are going to be about here. So those points are going to be well inside the cavity, the hole inside my mouth with nothing touching them, and the sound should still happen. I will have to blow a bit harder, but that will hopefully prove to you that when you blow fast air in, the air outside actually squashes them together, which is in my mouth. Watch again and listen. So those points weren't being touched by my lip that time. So we know it must be the air that's squashing them. Every time that point opens and the points open and close, we get a little puff of air travelling down the tube. And it's that puff of air which is actually causing the sound you can hear. And it sets up a wave going down the tube. Now the length of the tube affects the length of the wave. And the longer the wave, the lower the note or the lower the tone. So we can try different length tubes. For example, I cut this one a little bit earlier. Now you'll see if I hold them together, they are actually a little bit different in length. But I'll tell you what I'm going to do. I'm going to make them very different in length, even more so. Because in science, sometimes we don't actually have to measure, although this would be a good one to measure with a ruler, but we don't have to because we've made them so very different. If there is a difference, we can see why. Let me try this little one first. I want you to pay attention to the sound. Listen again. Notice the difference? Now I'm going to do it with the long one. Again, the little one. Now let's try the long one, see if you can hear any differences. Very different sound because the wave in here is longer. Now, one other experiment I'm going to show you. This is the dangerous Dr. Mark version. And actually, I was practicing this the other day and I thought, I wonder what will happen if while I blow this, I cut it with my scissors at the same time. And because I'm a bit mad, I was actually using bigger scissors because it was easier. I don't recommend you use these, I always use small ones. I don't recommend you do it like this either, but this is a bit of fun and I'm an expert at this. So watch carefully and see if you notice anything, because it sounded to me, you know, when I started cutting it, it sounded to me like it was very unhappy about being cut. See what you think. Rather annoying sound. Of course, I don't recommend that way because you might accidentally cut the end of your nose off, which could be a bit painful, or get the scissors stuck up your nose, and I don't recommend that either. So taking it out of your mouth and cutting it is the sensible scientific way.